You know, everything that makes our modern world tick, from the factories building our cars to the power plants lighting up our cities, it all runs on incredibly complex machinery. But what if those machines could talk? What if they could give us a heads up that they needed help long before they actually broke down? Well, that's not science fiction anymore. That's the promise of a technology called predictive maintenance, and we're about to dive into how it's completely changing the game.
So let's start with this question, because this is really the whole idea right here. It's the question that's driving a massive shift across all of industry. And it's a data-driven reality that is changing how we think about keeping our world running. But to really get how radical this is, we gotta look at how things used to be done. For the longest time, the main strategy for keeping machines running was brutally simple, and honestly, a little bit chaotic. It was called run to failure.
Yep, you heard that right. The whole philosophy was just to use a piece of equipment until it literally ground to a halt. I mean, can you imagine driving your car until the engine seizes up on the highway and only then deciding to call a mechanic? It sounds completely absurd, but for decades, this reactive approach was just standard practice.
And the consequences? They were exactly what you'd expect. A total nightmare. You're talking about massive, unplanned downtime that just brings a whole production line to a screeching halt. Sky-high costs, because you're paying for emergency, last-minute repairs. And really, just pure operational chaos. It is by far the most expensive and disruptive way to manage anything.
So yeah, obviously that had to change. Industry took a step in the right direction, trying to be a bit more proactive with a new strategy, one that was basically based on a simple calendar.
And this led to a new idea. Moving from that reactive fix-it-when-it-breaks model to a more preventive, time-based one. This is like your mechanic telling you to change your car's oil every 3,000 miles no matter how you drive. It's definitely better, for sure. It stops some failures from happening, but it's also incredibly inefficient. You end up throwing away perfectly good parts and wasting a ton of money on maintenance that just isn't necessary yet.
So, all that inefficiency really set the stage for a true revolution. A totally new approach that isn't based on waiting for disaster or following a rigid calendar, but on real-time, actual intelligence.
And here it is, predictive maintenance, or PDM. The core idea is so simple, but it's also profound. It uses a constant stream of data from all kinds of sensors to understand the actual health of a machine in real time. It's not about guessing or just hoping for the best. It's about listening to what the machine is telling you and then performing maintenance precisely when it's needed, not a moment too soon and definitely not a moment too late.
So how does this magic actually work? Well, it breaks down into 4 key steps. First, you have all these sensors, part of what we call the Industrial Internet of Things, or IIoT, and they are constantly monitoring everything: vibration, temperature, acoustics, you name it. Second, artificial intelligence sifts through this absolute flood of data, looking for these tiny, subtle patterns that signal something's starting to wear out. Third, really sophisticated algorithms use those patterns to predict the remaining useful life of a part. And finally, armed with that incredible prediction, maintenance can be scheduled with almost surgical precision.
Now, this whole process is only possible because of these incredible advances in artificial intelligence. AI is the engine that turns all that raw, noisy data into what is essentially a crystal ball for machinery.
This quote from some recent research just nails it. It's the combination of the IoT sensors collecting the data, big data systems processing it, and machine learning finding the patterns. That's the triple threat that makes this so incredibly powerful. And the result isn't just better maintenance, it's a safer, way more cost-effective operation all around.
And this just gives you a peek at the tech working behind the curtain. We're talking about some seriously sophisticated tools here. Things like deep sequence learners that can understand how data changes over time, and digital twins, which are basically virtual copies of real machines that let us run simulations and test for failures before they ever happen in the real world. This isn't just basic number crunching, it's the absolute cutting edge of AI.
Okay, so the technology is impressive, for sure. But what does it actually do? What's the bottom line? Let's look at the numbers, because the impact here is, well, it's staggering.
This one stat says it all. Companies that are actually doing this are seeing unplanned downtime, the most expensive, most disruptive kind, slashed by 30 to 60%. That is just a massive, massive improvement to how a business runs. And this chart just makes the business case crystal clear. You don't have to be an accountant to get this. Reactive maintenance is just wildly expensive. Preventative is better, but you're still wasting a lot of money.
But look at predictive maintenance. It consistently delivers the lowest overall cost. Why? Because it gets rid of both the crazy expensive emergency repairs and the wasteful, unnecessary work. So the bottom line is, it's not just smarter, it's a whole lot cheaper.
This is already a total game changer, but the technology is not standing still. Not even close. The future of maintenance is on track to become even smarter and more connected than it is today.
So what's next? Looking ahead, we're seeing some amazing stuff. Technologies like federated learning, which lets AI models learn from data across multiple factories without ever sharing sensitive, private information. We're even seeing people explore how quantum computing could analyze incredibly complex systems. The intelligence of our machines is only going to keep growing.
And that leaves us with a pretty fascinating thought to end on. We started this journey in a world where things just broke, totally unexpectedly. We're now moving into a world where machines can predict and even prevent their own failures. So I'll leave you with this question. In a future where everything can tell you what's wrong before it happens, what does it even mean for something to break anymore? Does the whole concept just change forever?